everyone, and welcome back to another episode of Math. In the last several videos, we've been talking about fractions, and unsurprisingly, we're going to continue talking about fractions. But you may have noticed that all the fractions we've dealt with have been exclusively between 0 and 1. We've dealt with nothing else. And that kind of makes sense, because if we look at the fraction 2/3, well, we're splitting something up into 3 pieces and shading in a piece of it. Fraction, right? We're looking at a portion of it, not the entire thing. But if we're looking at just a portion of something and not the entire thing, well, then it would make sense that it has to be between 0 and 1, right? Because 1 is like a whole number. It's an entirety of something, but a fraction is almost by definition not that, right? So how could we extend fractions to something other than between 0 and 1? But then we got thinking, well, fractions are just decimals, right? 2/3 we saw was the same thing as the decimal 0.6 repeating. And we know decimals go further, right? We have things like 1.5 or 1,000.123, or even in the negative direction, we have something like negative 0.3, right? So we know decimals can be extended. So if fractions are decimals, surely there's a way that we can allow fractions to also go beyond 0 and 1. But what would that look like? Well, to start, let's introduce one of my best friends, the improper fraction. So to talk about improper fractions, let's quote-unquote discover what they look like. So let's just consider 3/4 plus 1/2. Alright, simple enough question. We saw how to add fractions in the last video. We need a common denominator. So we're looking at 2 and 4, and a common denominator would be 4, right? Because 2 can be converted into a 4 pretty easily. 2 is a factor of 4. So we just need to multiply the numerator and denominator by 2 each. That gives us 3/4, and then a half gets converted into 2/4. Alright, so we add these up. 3 plus 2 is 5, and 5/4. So I have 4 things here. 1, 2, 3, 1, 2, 3, 4. How am I supposed to shade in 5 of them if there's only 4 of them? And this is what we call an improper fraction, where the numerator is bigger than the denominator. And you can go back and check my videos. We have never looked at one of these yet. It was always that the numerator was smaller than the denominator. Those were just regular fractions. But as soon as the numerator gets bigger than the denominator, that is what we call an improper fraction. Alright, so how does this help us out? And we haven't even answered this question yet. How am I supposed to fit 5 pieces when there's only 4 available? Well, what we're going to do is, what if we take another rectangle here, split it into 4 pieces as well, and now we can shade in 5 pieces, right? 1, 2, 3, 4. That's the first rectangle filled up, but then we can shade in 1 more piece, and that gives us 5. And now you might start to see why this actually will allow us to go beyond 1, right? A whole 4 out of 4, right? 4 out of 4 is 1. And then we've gone an extra quarter. So essentially, we can think of this as we've gone 1, and then we've gone an extra 0.25, right? 0.25 equals a quarter. So 1.25, we might expect, should be 5/4. And if that's the case, then, well, this would allow us to go beyond 1, right? It would allow us to take a fraction that represents a decimal that's bigger than just 1. And we see that pictorially here, if we're shading in more than the amount of pieces we have, that's basically going to force us to go beyond 1 and basically fill in multiple of these rectangles. So for example, if I consider 10/3, alright, so I'm splitting up a rectangle into 3 pieces. I'm going to have to do that for several rectangles. Alright, so let's shade in 10 of these pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since 3 of these rectangles are shaded and then there's a little bit more shaded, we would expect 10/3 to be somewhere between 3 and 4 on the number line. So if this is 2, 3, and 4, 10/3 is going to be somewhere around here. So improper fractions are going to allow us to basically get as big as we want with our decimals. Now, another way to think about this is, what if we converted it into a decimal? How do we actually directly go from an improper fraction into a decimal? Well, we know how to do regular fractions to decimals. We just divide the numerator by the denominator, and it's going to be the exact same thing here. So let's confirm actually that 5 quarters is 1.25. So 5 quarters, if we convert that into division, that's 5 divided by 4. And doing long division, we see right off the bat that 4 goes into 5 one time. Now, we've never seen that before, right? It was always a 0 there, and then we had to add a decimal because our numerator was always smaller than our denominator, so we were never able to actually fit multiple inside. But now we actually can. 4 goes into 5 once, so then we subtract off 4, we get a 1, and then now we're going to have to add our decimal, right? 5 is the same as 5.0, bring the 0 down. 4 goes into 10 twice. 2 times 4 is 8, subtract that off, we get 2. Add in another 0, and we get 20. 4 goes into 20 exactly 5 times, and what do you know? We get exactly 1.25. So this improper fraction gives us a decimal bigger than 1, right? And we can use this symbol here to mean it's bigger than 1. All right, so that's literally it. We now have a way to express decimals bigger than 1 by using these improper fractions, and they work just the same as what we're used to. And we should also figure out how to convert a decimal back into an improper fraction. So let's say I had something like 3.2. How do I put that into a fraction? We know it's going to be an improper fraction, well, because it's bigger than 1, right? But how do we actually convert it? Well, what we saw before when we converted decimals, for example, 0.2, we would take the number without the decimal and then divide by the power of 10 that was the number of decimal places we slid over by, right? So in this case, since to go from 2 to 0.2, we only have to slide the decimal over by 1, we just divide it by 10. So we see that 0.2 is the same as 2/10, which we could simplify into 1/5. However, with 3.2, let's try the same process. So 3.2, and then we're just going to write the number now without the decimal. But we actually have to include the 3 now, right? Because this isn't just a 0 to the left of the decimal, it's an actual meaningful number. So we have 32. And how many times was the decimal moved over? Well, to go from 32 to 3.2, it was only moved over by 1, right? So we're actually also going to divide this just by 10. So this is 32 over 10. And simplifying it, these are both divisible by 2, so we're going to get 32 divided by 2 is 16, and 10 divided by 2 is 5. So we get that 3.2 is the same thing as 16/5. So this is the improper fraction that represents 3.2. So I hope that makes sense with the improper fractions. We're going to get a lot of practice in the exercise video for this, but now I want to turn our attention to mixed numbers, which are actually also going to be used to express fractions bigger than 1. It's just going to be doing it in a different way and give us a slightly different perspective on it. So if we have 5/4, we just saw pictorially that we can essentially take multiple rectangles, split up into 4 pieces until we've filled up all the pieces, right? So 1, 2, 3, 4, 5. Now, one thing we can think about with this is essentially 1 and a quarter of these pieces, right? 1 plus a quarter will be the total amount of area shaded in, right? If this rectangle is worth 1, and then we have a quarter of that rectangle, it's 1 plus a quarter. And what a mixed number says is essentially it's going to be written as 1 and a quarter. So we condense this notation here with 1 plus a quarter to just become 1 and then a quarter. So this 1 represents the whole number piece, and then this quarter here represents kind of the fractional component of it. And what's kind of nice about this is that we saw that 5/4 was 1.25. But if we think about it as 1 and a quarter, well, we know that a quarter is 0.25, right? Well, 1 and a quarter, that makes sense. That's 1 plus 0.25 is 1.25, right? So this kind of may be a little more intuitive way of thinking of it, where it tells you the actual whole number you're at and then how much fraction you need to go. And this is also kind of nice because in a sense it kind of tells us that the incomplete part of a number always has to be between 0 and 1. Right? The distance between one whole number to the next one is always worth 1. So that means if we're going only a part of the way, that fractional distance is always going to be between 0 and 1, right? With a mixed number, we never have an improper fraction with the number, right? So we could have 2 and 3/5. That would be a valid mixed number. What that means is we've essentially gone to 2, and then we go 3/5 of the way to 3. So that would be 2 and 3/5. Or we could think about it as we have 3 rectangles here, 2 of them are shaded in, and then the last one split up into 5 pieces. 3 of those pieces are shaded in. So it basically just gives us another way to write a improper fraction. So now the question is, how do we convert these mixed numbers into decimals? So the way we convert it into decimals is let's take this 2 and 3/5. Now we recall that 2 and 3/5 is the same as 2 plus 3/5. So now all we have to do is convert 3/5 into a decimal, and then we just add it. So 3/5 converted into a decimal is 0.6. So 2 and 3/5 becomes 2 plus 0.6, and we get 2.6 just like that. So it's not too hard to convert a mixed number into a decimal. You just basically chunk off this fractional piece and do what we already know how to do with converting it into a decimal, and then add it back together. And we see here then, okay, 2 and 3/5, that's actually just 2.6. And converting from a decimal into a mixed number, let's say we have something like 11.7. Well, for this, it's actually pretty simple because the mixed number is the whole number and the decimal part. So we can immediately just split up the whole number, which is 11, and then add the decimal part, which we're going to convert into the fractional part. So now all we have to do is convert this 0.7 into a fraction, and that's done as 7/10. And then when you have a whole number plus the fraction, that just becomes the mixed number itself like that. So this would be 11 and 7/10. So this is another way of using fractions to represent a decimal. So a lot of people, they prefer mixed numbers. They think it's more intuitive because, well, it tells you the whole number you're at and then the fraction that you have to go to just move a little bit further. So mixed numbers are more intuitive. However, ultimately, you're actually going to end up using improper fractions more, because improper fractions, as we're going to find in the next few videos, are much easier to do math with than mixed numbers. A lot of the time you're doing math with mixed numbers, you're going to actually end up converting them into improper fractions, which I will teach you how to do in the next video, and then do the math there. So you're going to find that it's actually easier to work with improper fractions despite mixed numbers being more intuitive. But it's still important to know both ways. And again, we're going to get a lot of practice in the next video on that. So what have we done so far? We've just shown 2 different ways to represent decimals that are bigger than 1, right? We saw fractions can represent decimals between 0 and 1, but now we can use fractions to represent any decimal, right? 1,000.329, 3,000,000.1473. All those can be represented either as mixed numbers or as improper fractions. But now, we also have this entire direction we can go, right? In the negative direction. So can we look at negative fractions? And the answer is yes. So let's consider something like 1/3 minus 1/2. All right, so if I convert these into something where they have a common denominator, the common denominator will be 6. So 1/3 multiplying the numerator and denominator by 2 will give us that common denominator of 6. So we get 2 6s. And this 1/2, you'll see, is going to be 3 6s. 2 minus 3, that's -1, right? So we actually end up getting negative numbers, right? And we got that with regular whole numbers too, right? If you subtract a bigger number from a smaller one, that takes you into the negative numbers, right? So similarly with fractions, you subtract a bigger fraction from a smaller one, you're going to be going into the negative numbers. And the way we can interpret that is just, well, it's the same thing as a regular fraction, just in the opposite direction, right? We kind of discussed that in our perspectives of negatives, that a negative is just kind of the same size, it's just in a different direction. So if 1/6 is right here, between 0 and 1, -1/6 will be the symmetrical version of that, just in the opposite direction. So the same distance from 0, it's just going the other way. All right, and then we can also consider improper fractions that are negative, right? Something like -7/3. That can be converted into a decimal. You're going to see that that is the same as -2.3 repeating. So we can express negative decimal numbers as an improper fraction with a negative in front of it. And then similarly with mixed numbers, we can do the same thing. We'll see that this is going to be the same thing as just -2 1/3 right here. Now there's a small caveat with mixed numbers. I said that something like 2 1/3, that's 2 plus 1/3, right? But negative 2 1/3, that won't be negative 2 plus 1/3. That's just going to be negative 2 minus 1/3. So we have to think of this minus as affecting this entire mixed number here. So we introduced a lot of different things in this video. So if you were confused by any of it, please feel free to leave a comment or go back and watch that part of the video a couple times until you feel like you've got it. But don't worry, because there's a practice video coming soon where we're going to get comfortable with all of these concepts. And fractions, quite frankly, are something that you are going to use pretty much forever in math. So you're going to get used to them. But I hope you found this video useful. I hope you found it interesting. And now you can do fractions literally wherever you want on the number line. You're not bound between 0 and 1 anymore. The world is your oyster. And while you're enjoying that oyster, I'm going to be preparing the next video. So until then, you have a good one. Stay groovy.
And I'll see you in the next video. I'm Walter White, and I love F.O.A. maths.
F.O.A. maths.